Okay, so here's how we're going to get the data for this lab. So first you're going to open up the simulation page and go to the one with the cannonball, or the cannon that says lab. Click that one. All right, it's going to open like this. And what we really want is only to just drop a ball through the air. Okay, we don't really want to fire it, but it was hard to find a simulation for that. So we're going to drag this cannon up to the top, okay, and then rotate it around so that it's at -90, so it points straight down. Okay, and then go ahead and drag it all the way to the tip top, which would be 15, okay? Don't change anything on the right, just leave it, all right? And then what we want to do is I'm going to go ahead and put it on slow, okay? And we just want to drop the ball. We don't really want to fire it because we want its initial velocity to be 0. So let's go ahead and just move that slider on the bottom left down to 0, okay? All right, so then you're just going to hit the little red button at the bottom to fire it, okay? And we're not really firing, we're really just dropping, okay? So you can see the ball as it falls, okay? And what we want is we want this data of the ball in what we call free fall, only under the influence from the pull of the earth, okay? No motors, no air friction, no wings, no, nothing on it. It's just freely falling towards the earth. All right, and then pull this little tool over so you can get the data, all right? So the first thing you want to do is start at the top, so that's going to be 0.15. Okay, so then go ahead to your data table, and 0.15 should already be filled in for you. I had to fix this one. All right, and then you're going to go back here, and then you can get 6 more data points. Okay, so it doesn't really matter which 6 you get, but see how up here there's a whole bunch of tiny ones? Okay, and then down here the points are a little more spread out. So try to get kind of a range, right? So you might want to go every, 0.2 seconds. It doesn't really matter what you pick, okay? But let's say I'm going to try to go, wow, 0.2 is way up here, okay? 0.2, 14.8, okay? So then I'll put that in my 0.2, 14.8, all right? And then I will go maybe to 0.4, and it doesn't have to be even. It might be easier on your math if it is, but it doesn't really matter. So 0.4, 14.22, 0.4, 14.22, okay? 0.6, 13.23. I don't know. I feel like maybe I should have picked a bigger value, but whatever. 23. You might want to pick every 0.4 seconds. I don't know. It really doesn't matter. Okay. And then 0.8, 11.86. Okay, etc. 11.86. Okay, and again, look, I'm only going to make it to 1 second. Okay, so you really might want to spread it out a little further when you do it because it's going to go all the way to like 1.7 seconds. So maybe you want to go like by 0.4s or something just to get a little bigger range is fine. But again, it doesn't really matter. Okay, all right, so that's how you're going to get the data. Then on your document, we need to go through, because what we really want to do is we want to make a velocity versus time graph, okay? And we want our initial velocity to be 0. We set that, all right? And then we want to create a graph. So this is just like we did in early 3A, okay? Where if you remember what we did was we did the delta t, okay? So this is 0.2. In this case, every time, but it doesn't have to be. It can be whatever your values are. It doesn't have to be consistent, okay? And then we do the delta x. So 15 to 14.8. Okay, that's technically going to be negative 0.02 or negative 0.2. All right, but really we just want the down direction to be positive. So it will work out if you just kind of do the delta and just like kind of like take the absolute value of it. So don't really worry about the fact that it's negative, because then that's going to make us moving in our positive direction. Okay. All right, so then you're going to get your average velocity here, right? What we did here, which was 0.2 over 0.2, so that's going to be 1. And then if you remember when we did this before, if the average velocity in this interval is 1, that's also the instantaneous velocity at the middle time. So you're going to have to reach way back to 3A for this. So my middle time is going to be 0.1. Okay, then here I'll take this value and put it here. What is that? 5.8. Okay, so 0.58, and then divided by 0.2, 0.58 divided by 0.2 is going to be 2.9, okay? And then 0.2, 0.22, whatever that was, okay? And then that's going to happen at the middle time here, which is 0.3, okay? And then et cetera, et cetera, et cetera. All right, so you're going to do that like before. If you need help, just ask. And then this here is what you're going to graph on your velocity graph. All right, so we're going to graph the average velocity in the interval at the middle time. Okay, just like we did before. This will be good review for the final too. All right, after you do this, hop onto Desmos, graph it. Okay, if you can't remember how to get that equation, if it ends up looking like a line, you're going to do y1 squiggle mx1 plus b, and then that's going to give you the y-intercept, the slope, and the equation. Okay, and if it doesn't look like a line to you, then ask me. If you need another shape equation, I can give that to you. Okay. All right. And then once you get all this data, you're going to put this, answer all these questions. And if you're doing this in class, maybe you put it on a whiteboard or on your paper, depending on what your teacher says. Okay. And then we'll do a wrap-up video in a second. All right. So that's how you get the data.